We just looked at the behavior of the function as it approached an asymptote. Now what we want to do for that same function, f of x equals 1 over x, is consider what's happening to this function as it approaches extreme values for x. And I'm just going to change this. Consider what happens as this function approaches extreme values for x. Meaning, as x gets incredibly large and x gets incredibly small, what's the behavior of our function? We'll start by tracing our curve in the direction of x getting larger and larger and larger. And what we see is this behavior where our curve is getting closer and closer to the x-axis. And if we trace our curve in the negative x direction, so as x is getting smaller and smaller and smaller, we see that same behavior. That curve is getting closer and closer to the x-axis, which tells us that as x approaches positive infinity, our function f of x approaches 0. And as x approaches negative infinity, f of x is also approaching 0. We have that same behavior whether we trace the graph to the right or trace the graph to the left. In both cases, it's headed to the line y equals 0, which means we have a horizontal asymptote which we can also represent as a dashed line, so sort of an invisible line that as our x values increase to very large and very small values, our function value will approach closer and closer to that value. We refer to this type of discussion as looking at the end behavior of the function. So what's happening with those extreme values of x, or looking at the tail ends of the function. And we use some notation similar to what we used with local behavior. Here we'll say that as x approaches positive infinity, which was what we traced as we traced that curve to the right, our function f of x is approaching 0. And as x approaches negative infinity, which is that behavior that we saw as we traced the curve to the left, f of x was also approaching 0. Whenever we end up with a number value here, like we did in this case, 0 and 0, that tells us that we have a horizontal asymptote, and the equation for that asymptote is y equals whatever that number is that we came up with.